Welcome to Power Electronics video series. In this video, I will explain the main concept of power electronics. Then I will show you the different types of power conversion done by power electronics. Let's assume that we have a battery that provides 12 volt DC and we want to turn on a load that needs only 6 volt DC. Obviously, there is a voltage mismatch. How we can connect them? One way to connect them is to have an additional load that forms voltage divider with the desired load. Each one of these two loads will get 6 volt, but the additional load consumes unnecessary power. Instead of having additional load, let's have a switch. An oscilloscope is used to view the voltage across the load. When the switch is open, the voltage across the load is 0. When the switch is closed, the voltage across the load is 12 volt. If we keep switching on and off, the voltage across the load keeps changing between 12 volt and 0 volt. 12 volt when the switch is on, 0 volt when the switch is off. If we manage to make the on duration and off duration exactly the same, then the average voltage appears across the load is going to be 6 volt. A better way to connect a 12 volt DC source to 6 volt DC load is to use high-speed switch, that is power electronics. If switching speed is 1 kilohertz, then the period is 1 millisecond. Since the required output voltage is half the source voltage, then duty cycle should be half or 50%. Duty cycle is the ratio between the on time and signal period. To get the value of the average voltage for any ideal switching circuit, we just multiply the source voltage by duty cycle under the following assumptions. No voltage drop across the switch, that means its resistance 0, and it goes on and off immediately. Power electronics is mainly about special circuits called converters. Those converters are used to change the voltage form from AC to DC or DC to AC, and sometimes they are used to change the voltage level. In power electronics, there are different types of converters. The one that converts AC to DC is called rectifier, and the one that converts DC to AC is inverter. And chopper usually converts DC to DC but at different voltage level. And finally, cyclo-converter converts AC to AC at different frequency. To explain the idea of these converters, here are some examples. We have an AC motor that actually needs to be run at 30 Hz, but the supply voltage is AC with different frequency, 60 Hz for example. Then cyclo-converter is needed to convert AC to AC at different frequency. Another example, when we have a DC supply that provides 12 volt but the load needs 24 volt DC, then chopper circuit is needed. A third example, when we have an AC power source and DC load. To convert an AC voltage into DC, rectifier is required. The last example, when we have DC supply but the load is an AC load. To convert DC supply into AC, we need an inverter. The components that are used to build those converters belong to different families, such as diodes, transistors like bipolar junction transistors and field effect transistors, in addition to thyristors.